Everyone, welcome to the video. Today we are going to solve construct binary tree from Inorder and Postorder. So first of all, I will reiterate that in order you have left root, then root, left, then root, and then right element, right? Left element, root element, then right element. And in post order, you have left element, right element, then root. So post order assures you the last element will be the root of the entire tree, root of entire tree, which is in example one, which is the case one over here, right? And when we constructed, one came as a root. Right? So how we'll do it? So I'm just doing this question in Java since in Python they have some issue. I will tell you what issue is. So here you can see this function. It takes three arguments, but when it is called, see it is called as an object of something, right? Object of the solution, and here it appears as a takes four arguments, so it will cause an error, which is why I'm solving this question in Java, which makes it much more easier. Okay, so first of all I'll create an array which will store the index of post orders. Okay, store one element in it, which is n minus 1. Fine. Then I will solve this question using recursion, and I will create a function solve, let's say, and I will pass few parameters such as the Inorder traversal, then post order traversal, this post index array which I calculated, then three more parameters. I will say one will be the start of the Inorder traversal. Okay, okay, I will say in start. No, but since I have to pass as parameters, so I will say start of the Inorder index and end of the Inorder index, Inorder traversal, along with the value n which we have, right? So I will create these functions. Cool. So I'll create these functions. Be of type node. It will be of type node. Yeah, it should be of type node. First of all, in-order traversal, and then we have post-order traversal. Then we have post-index, post-order index. I'm writing it post-index, but its name is post-order index. Okay, index of the post-order all the post orders. Since it will be big, that is why I'm writing it in short. So then starting index of the in-order traversal, ending of in-order traversal, the current chunk which we are calculating, and the value and total number of nodes, right? The first base condition, the post index, if the post index is less than 0, if the first element is less than 0, or apart from that, if we are we have moved out of the bound, if we have moved out of the bound, we'll return null. We will return null. But if we are within the bound and it is not 0, then in this case I will store one element. Let's say I store value x. Okay, then what will be it? It will be the post index, the first value which is in the first element, the post order index, post index. Okay, one element, and then I will create a root of type node, which is containing this value, just containing this value, this element x, which I just fetched. I'll convert it into a root node. Okay, because this is the basically this is our node, as I mentioned in the beginning of this video, that in post order the last element of the post order is our root, right? Now let's say I'm creating a position value, then I will again call this function I'll call again a new function. I'm passing parameters over here. Should be. We'll pause the video. Okay, so I'm calling another function. I'm passing parameters over here, which is the in-order traversal first, and then the starting point of the in-order traversal, ending point of the in-order traversal, which was in start and in index in end, along with along with along with the value which we just found out, which was x, right? Now how we'll do this one, I will there are remaining points in this function, but first of all I will solve this question so that there remains a continuity in our video. So I will solve and form this function. Since in order is an array, apart from that, in start, in end, these is x, these are integers. So what will it check? It will traverse the entire in-order traversal. It will traverse the in-order traversal array. Start from in start, goes till in end, one element at a time, and it will check if ith element of in-order traversal is this. So we are finding the position of this particular element. We are finding the position at which this particular element is. If it is not present, we will return -1. If this element is not present, we'll return -1. Okay. But if we have found out this element, we'll find its position. Okay. Then we'll come back to the main function, to the utility function, which is solve. And now that we have found the position of this particular element, okay, now we'll use this element's position, this element's index, okay, in order to understand where should we place, what should the root left element and the right side, okay, left and right side. So first of all, I will use right element, call recursively this function. This time in order, then post order, and then post index as it should be, and the real play starts. In place of in start, in the beginning element, starting element of the in-order traversal, we'll use position +1 because we have already calculated till position. So now we'll start from position +1, goes till in end using the element, okay, and then root dot left, call it again same in order, post order, and post order index, but this time we'll start from in start, okay, and we'll go till position -1. If you can see, we have already calculated for position, so left will be prior to position elements, okay, prior to this element, which is position -1. Okay, start from in start, goes till position -1, goes till position -1. And in the case of right side, so when we are at the point position, okay, index position, then right subtree will obviously be at the right side of this position element, okay, position element, right side of this position element, which is position starts from position +1, goes till in end. Dn our return our root. Let me submit and compile it for the test of our efficacy. Okay. Okay, sorry. I will submit it again. Yeah, this time it does the job pretty effortlessly, as you can see. And despite being a recursion, since we are using Java, it is not taking very large amount of time. So I hope so. This question is quite easy, but it contains a lot of formations. We have to reach a particular stage when we need to extract that information and use it further. So this is what you have to think of. So I hope you enjoyed this video and learned a new concept. Thank you. Have a very nice day.